This is the Chapter 28 video on the divergence test. So as a rule, I don't state the theorems and definitions that are already in your notes. I'm going to make an exception here because I actually want to explain why this is called the divergence test. So the statement is, if the series converges, then the limit of the sequence is equal to 0. So the question is, why is something called the divergence test when it doesn't have the word divergence in it? Well, we look at the contrapositive, and that says if the limit isn't 0, which means the limit either doesn't exist or is something other than 0, then the series diverges. And so that's how we use the divergence test. We look at the series, and then we take the limit of the sequence. If that limit is something other than 0 or doesn't exist, then your series diverges. And so we can test the series simply by looking at the limit of the sequence. So example 191, we have the series we have part A is a series n equal 1 to infinity of n factorial divided by n squared. I had part A from another example up there, but this is the example we want to look at. Now, what is n factorial over n squared? Remember, n factorial is n times n minus 1 times n minus 2 we just take the product of all the natural numbers between 1 and n divided by n squared. For n greater than 3, greater than or equal to 3, n factorial over n squared is greater than or equal to n times n minus 1 times n minus 2 over n squared. And if you recall from Calculus 1, the limit as n goes to infinity of this is infinity because you have a third degree polynomial over a second degree polynomial. So the limit as n goes to infinity of n times n minus 1 times n minus 2 divided by n squared is infinity. This is something we learned in Calculus 1. This implies that the limit as n goes to infinity of n factorial divided by n squared is also infinity. So this sequence diverges. It does not converge to 0. Therefore, the series n equal 1 to infinity of n factorial divided by n squared diverges by the divergence test. Part B, we have the sum n equal 1 to infinity of n divided by n plus 1 to the square root of n. before we look at this directly, let's recall something. The limit as n goes to infinity of n plus 1 over n to the nth power is the limit as n goes to infinity of 1 plus 1 over n to the nth power, which is e. This is the definition of e. This means that the limit as n goes to infinity of n divided by n plus 1 to the nth power, this limit is the reciprocal of this one, which is 1 over e. We are going to, when we look at the sequence, we're going to compare this sequence to this one. And so we'll apply the divergence test by calculating the limit as n goes to infinity of n divided by n plus 1 to the square root of n. Now, n divided by n plus 1 is smaller than 1. So, if we make the exponent larger, we make the fraction even smaller. So that is greater than or equal to the limit as n goes to infinity of n divided by n plus 1 to the n, which is 1 over e. This term is smaller than this one because n divided by n plus 1 is less than 1. So that means that this limit, therefore this limit that we were calculating, is not 0. That implies that the series diverges by the divergence test. So the series 1 to infinity of n divided by n plus 1 to the square root of n diverges by the divergence test.